So basically, as part of like improved deletion support, so we have added three things. So basically, one is like deletion APIs. Basically, all REST endpoints have been updated. So to support time series aspect deletion. So we also have support for rollback and retention, basically. So this is the new stuff coming that we have managed to ignore so far for time series aspects. So these are special things that basically live only on Elastic right now because of their nature. So yeah, that's basically the sort of improvement. So you will see in the docs once the feature rolls out, what exactly are the changes, but at a high level, we allow you to basically specify additional parameters for time series aspects. So when you do delete, rollback, it's like there is no change in the API. It just deletes basically time series aspects as well. And retention, basically, it's like it's index lifetime management policies that allow you to tell like when to start cleaning up old data. So that's like at a high level what it is. So I'll get to the demo. I'm going to demo like two most like commonly used use cases for each of these. So I'm going to start with deletion. So okay, here is my demo data set. So if you see, there are so for this I want to use basically the dataset profiles time series aspect. Here there is no data right now. Let's go ahead and magically ingest some data in there. Okay, so this is my secret script that has ingested about, I think, 10 aspects, I think. So stats. Okay, now if we go to the historical view, okay, so we have about 10 of these. So stats. So now I basically don't want this. So I want to basically go ahead and one very common use case is deleting the entire platform itself. So what happens today is like when that is done, the time series aspects don't get deleted. So let's basically now see that they get deleted. So with the new code. So this is files. So if we see dataset profiles, after ingestion, there are 10 docs, yes, as expected. So now I'm going to run the deletion command that some of you might have already used. So it asks, we go ahead, do that, deleted 13 rows. Earlier it used to say 3. Time series were not like included as part of that. So let's go check our Elastic index. Okay, gone. So they are gone. If you go check here, that should be like, okay, nothing. So that's basically that one. So to show quickly how rollback basically works. So this one, DataHub, I'm going to ingest operational stats basically. So through this one. So this is my recipe for the demo. So it's gone ahead. So, and if you look at the operational aspects, okay, refresh, should show 4, yeah, good. So now I'm going to basically do our standard list runs. So, it is basically this one, test redshift usage run. So that run I'm going to basically roll back. Okay, go ahead. Okay, done. So now if we go check the Elastic index, you shouldn't see any dots left here, gone. So that's about it. So I'll hand off to basically Pedro.
All right, thank you very much for that, Surya. So continuing on this idea of deletes, I want to give you a little bit of a story or a little bit of background on some of the missing features or behaviors that you might naturally expect and might have encountered in the past, particularly around deleting metadata references. What this means is, in the past, if you tried to delete some metadata that was being referenced somewhere else, so typically, let's say you have a tag that has been used in multiple data sets, and if you delete that tag, by default, when you were running or using DataHub CLI to delete that tag, we didn't delete these references. So we would have things, we had what I would call our ghost references in the UI. So the tag would still appear in your data sets in the UI. And this is what we call dangling metadata. And the way that we had to fix this issue up until now was to manually identify where all these references were and then issue MCPs to actually unset that property which was no longer valid. However, this was both confusing for users, like not the expected behavior in some cases, but also occupying space in DataHub's databases, right? And in our graph indices. So this was taking a lot of space, but that's no longer the case. With that in mind, let me show you a little demo. So in this case, hold on, right. Here we are. So suppose that you have some data set, right? This currently is tagged with nothing, has no glossary terms, has no domains. Well, let's just say that I want to add some tag here, and I want to exemplify what has been happening up until this stage. In this case, I'm going to say that browser ID is some PII. So I'm going to create a tag based on that, okay? And I have this tag. What I'm going to do right now is just get its identifier, which is up here, and I'm going to delete it as that would happen right now. So delete dash dash earn, we pass it the ID or the earn of the resource that we want to delete. This would have to be a hard delete. And then I'm just going to add a flag old, which I implemented just for demo purposes, to exemplify what has been happening in the past. So do I want to delete this? Yes. It says that it deleted it. Okay, that's all fine. I refresh this page, and yet I still have a reference to a PII. However, if I search for it, let me just put, I want to search for everything and search my tags. It's not here. Like this does not exist. So this is the inconsistency that we had in the past. Right now, if I, on the other hand, do something like just set a domain for this, let's say that I want to create a domain called sales, for instance, and I want to tag that data set with this domain, right? So I'm just going to come here and I'm going to add it. It's being referenced right here. And I'm going to do the exact same thing. I'm going to try to delete this domain, so deleting not only the entity itself, but also the reference that this data set has. And that is done simply by deleting, passing it the earn dash dash hard. Notice that I'm not using the old version. Now this is the new logic. Oh, sorry, not run, earn. There we go. And it will say yes. And you will notice that in the case that you're trying to delete some entity which is being referenced somewhere else, we will provide you with a summary of where those references exist. For now, we're just showcasing 10 references, but you will have the total number of counts across the entire metadata graph. So this is a matter of, do you want to delete these references? Yes or no. If you say no, it's the old behavior. If you say yes, we will clean up everything for you. So if I now refresh the page, the domain is no longer set. And if I go into domains, sales is gone. So that's it from my demo. There are, however, two things that I still want to mention. So let me go back to my slides. And these are a couple of caveats. The first is that this logic is currently only being applied for deletes by earn. So when you specify dash dash earn, and specifically when you do a hard delete, because that's when you delete from the databases. When you do a soft delete, it doesn't appear in the UI, but you still have it in the database. That still holds. And the second thing is that computing these dangling pointers, so figuring out where they are in our metadata graph and generating the necessary updates across the entire graph. Right now, this is a synchronous operation. It might be a heavy operation if the entity that you are deleting is referenced in tens of thousands or millions of places. to give you a little bit of notion of the performance, removing 1,000 references takes roughly 8 seconds. Removing 15,000 takes roughly 50. So as you can see, this scales. However, we will be very shortly releasing or working on a second iteration of this project where we will address these limitations in the very near future, so you don't even have to worry about it. We'll make the processing completely asynchronous and by making it asynchronous, it's no longer on the blocking path. So operations like delete by platform, delete by registry, even potentially rollbacks, that's something that we will be able to do and make it consistently. So yeah, that's what I had on my side. Thank you very much. And I believe right now it's Ryan.
Yep. Thanks so much, Pedro. Thanks, Surya. Great job, y'all.